All right, hello ladies and gents, let's talk circles today. So I have some somewhat short notes that's going to get you started kind of in our final unit, which is going to be about circles. The first thing we have to do with circles is understand how to quantify them, not qualify them. And if you don't know the difference of the two, it's the precise difference between being able to do some calculations with something versus being able to simply describe it, okay? So you have your notes, we have this. So let's get working on circles. So just as a reminder, being a video, obviously pause as much as needed to get the questions down, go over the parts again if you're not quite sure. But your goal by the end of these notes will be to explicitly be able to define a circle both with a description and by an equation. And if you're listening to my intro, be able to quantify stuff with circles, meaning do some calculations with them. So let's start with this. Like, how do you actually define a circle? Not only by how it looks, but how it's created. And again, this is a quantity versus quality thing. And so if we're just going to describe a circle, we kind of already know how to do that. We've done that for years. We're just talking about a round 2D objects with no vertices, etc., etc., etc. I'm not going to bore you with the full description of circle because, frankly, you guys have worked with circles for quite a long time. So this descriptive definition of a circle is one that really since the beginning of the year I've been railing against because honestly it's just not that useful. This is like the common knowledge stuff about circles, and of course it's useful to know this stuff when you're just kind of talking about circles, but it's not very useful if you're going to do any actual high-level mathematics with circles. Instead, you have to turn to the actual definition. The quantitative definition, in the sense that with this definition we can do some calculations. If you kind of recall, like we've talked about pretty much all year, a circle is defined to be a collection. The term locus is important here. Locus means a collection of all points equidistant. Of course, that's going to talk about the radius from a given center, which is defined in general or by default to be HK. HK is the center of your circle. The reason why this definition has to be kind of paired with the descriptive definition because it's more useful when you quantify or just simply do math with circles. Okay, and so in terms of our work, in terms of what's going to be useful to us, this is going to be what we're going to lean on. Of course, we should always be able to describe a circle, but if we're going to do any really meaningful work, we have to be able to define one too. Okay, and so with that being said, if we focus on the definition of a circle, we should be able to start like mapping this out, and that's where the quantitative stuff actually starts coming into play. So in terms of our big question for this section of the notes, what are the key features of a circle map to the graph of a circle? And my grammatics aren't very good, but you know what I'm kind of getting at. So like, how do we actually like pull out key features from the definition and then get those on a grid itself? Well, the key features are going to come directly from the definition. So definition says it's a locus of all points equidistant or a radius away from a given center HK. And so those are the things that we're going to have to get onto the circle. The first things first, we need to get a center HK onto the circle. So using intuition, we're definitely going to be using this point right here as being our HK. Let me get a thinner pen here. So like that center, that's going to be our H comma K. And this is going to be the center of our circle. And so this is like vital information. If you're going to be working a circle, you have to know the value of HK. Now, specifically, we're going to be dealing with kind of 0, 0 here. Second thing, we have to get a radius. Well, the radius to any point, which we're going to call R for the radius, it has to, of course, start at the center, but can kind of shoot out in any direction as long as it hits a circle at some point. And so we can represent that by simply drawing a line segment. Hey, oop, what happened there? We can, by drawing a line segment, but noting that I can put that really anywhere on the circle being the collection of points in green. I'm just going to kind of stick it here in the first quadrant to make it easy, but we're going to definitely call this guy the radius R. Okay. Now this last bit's a bit tricky. From the definition, we know it's a collection of all points. And so we're looking for this radius to kind of be in any direction. And what we do know about the point is that it's defined to be x comma y. What that means is the radius really serves to connect the center HK, in this case 0, 0, to any point on the circumference of the circle, which we're just going to call xy. I know I'm on a grid and could probably give that a specific point, but really I want to keep it general because I'm just trying to map out the key features. And so the note I would like to make here is this represents, and this is going to be kind of weird, it represents any one point, but also all points. Okay. The reason it does that is because we are specifically choosing one point to be on the circle, the green circle itself. But since we're keeping it as an x comma y, it can really be any point in the circle, therefore representing all points on the circle. All right. Now I'm going to get into detail about what that means. But if you're asked to map out the key features or identify the key features of a circle, this is to what we're referring. So for any circle, you have to know the center, you have to know the radius value, and you have to be able to map out any x, y that occurs on the circle itself. Now that leads us into the next question, which is probably one of the most central algebraic questions that we could possibly ask you as a school. What does it mean to actually create an equation in math? Now my guess is this is not something that's been overemphasized in your previous courses or your previous algebraic work, and so you may come here not really understanding what an equation is about, and so that's why maybe the last section seemed kind of weird, especially with that XY thing, because unless you have a good understanding of what equations serve to do, then the X and Y serving to be any point and all the points at the same time might be kind of weird. So here's how I'm trying to help you out with this. So I'm going to take a little aside from the notes, and so just kind of relax and pay attention to what I have to show you, and you might be able to pick up on what I'm trying to tell you about these equation things, right? So here I'm just using a program called Desmos, and it's a graphing software program, and so I've mapped out a bunch of points here. Now please note that these points are x comma y values, and so this kind of falls in line to what we talked about in terms of circles, where you're kind of mapping these x and y values, right? And so I picked a few here, I label them out, you can see the color coordination, and so they're starting to what we call pattern, right? Or they're starting to map a pattern, it may be a better way to say it. And so if you're going to try to create an equation out of this, you're really kind of doing two things at the same time. One is you are noticing that there is a pattern forming with the values x and y that I've been choosing, and then two, you're trying to figure out a good starting point. Now you have lots of experience with this kind of pattern, so hopefully in your mind you're already thinking, hey, this looks like an awful lot like y equals mx plus b. Okay, y equals mx plus b being the general form for all linear equations. And so if you know that this is kind of your equation, you can kind of play around with the m value, which represents the slope, and you can kind of play around with the b value until everything kind of lines up, and you can kind of determine then this equation really is y equals 2x plus 1. Okay? Now what the equation itself right here serves to do, and again the equation came from noticing that there's kind of a pattern in the points that I've been giving you with the x and y values I've been giving you, and then two, choosing a nice starting point of a known equation and then kind of adjusting your values, is you now have a mapping that can tell you any x to any y for the same pattern. And ultimately, that's the whole point of an equation anyway. It just tells you how to get from x to y to form a very specific pattern. In this case, the specific pattern is a line, but that's all this equation does, is just kind of tells you how to map one to the other. And now that you have this mapping, we can start to create more points that we didn't have before. So we didn't have an x value of negative 1/2. But now given that all we have to do is multiply negative 1/2 by 2 and then add 1, we should be able to determine that this value should be 0. And you notice when I graphed it, it popped up right here on my patterned line, meaning that this line does predict future values for x and y. Okay? And so again, that's the whole point of an equation, is that it's just supposed to help you map out all the x's and y's you could ever use. Now, of course, we use a simple example, a linear equation, but this applies to all things that have curves or lines on a mathematical grid. And so if you think about this big thought, an equation just maps all the x and y points that comprise your curve. Now, curve in mathematical sense means lines, and also non-linear things like circles. And so like we can kind of shift our question. If we want to create an equation for this circle, we just have to figure out how to calculate all the points so they land in this nice curvature circular pattern, right? And so like the big takeaway from also the previous kind of Desmos example is that we don't have to do this from scratch. The most common strategy is just kind of noticing a structure and then starting out with something that's known within that relationship that you're seeing. For Desmos, well, it was a line. It was a y equals mx plus b equation. But for us, maybe something else has to evolve. But having said that, let's just get back to like maybe the structure itself. Maybe something will evolve. And so if we kind of recall, this was a center, h comma k, and specifically it had the coordinate 0 comma 0. Both are going to be important to this thought process. We had a radius that kind of emanated from the center, and it connected us to points on the circle circumference. And so again, I'm just going to kind of choose one. I think mine was about there before. That was a radius of r. I'm calling it r because I don't really know how long that radius is. Wink, wink. I know we can kind of count at this point, but just go along with the demonstration for now. And that connects us to a point xy on the circle circumference that represents really any point. One, because it's a variable xy, but two, because I could have put it anywhere and this picture would remain kind of the same. So if like your mathematical brains are going off right now, what you're probably noticing is that if I take this picture, I can quickly modify it to something that I'm extremely familiar with, which would be a right triangle. Really where if I stop this radius anywhere along the circle itself, like if I take this radius, I'm going to pop one back out here again, okay, and I stop it anywhere on this circle circumference, I can definitely construct this right triangle over and over again. Now, the reason why the right triangle is important is because we're extremely familiar with how to calculate using right triangles. So the known structure to which I was referring before should relate to like this picture, because we are looking like for the pictures itself, which means that really to write a circle's equation, we're going to start in a very familiar place, which is the Pythagorean theorem. Okay, so we're going to start with a squared plus b squared equals c squared. Okay, now we do need values to put in this equation, and ultimately what we're going to do is convert this so it can use the radius and the x and y values in the center. So our goal is to start with a squared plus b squared equals c squared, and then we're going to convert it to use hk, r, and then also x comma y. Okay, now that seems like a monumental job, but it's really not that bad. We just have to figure out what the a squared and b squareds are, because the c is already r squared. Okay, and so we have to figure out a length right here. Now to do that, it may help to get this point, or at least to define this point, and it's really not that hard to do. Now when I say define the point, I don't mean to count the grid lines, because the grid lines I don't think are really important at this point, but we should notice like this goes from, in terms of x values, from 0 to x, which means this coordinate here should also be x, and then the y values go from 0 to y, which means that the y value here should be 0, because it's still on the same flat line, and then this purple line will represent the total y change from 0 to y. So in terms of like how long this section is, well, we are just going from 0 to x, which means this is exactly x long. And if we look at the purple line, we're going from 0 to y, which means it's exactly y long. Okay, so if we look at our Pythagorean theorem, we're going to start with a squared plus b squared is c squared, and we're going to need to convert it so it's using like the x's and the y's and the r's. Well, instead of a squared, I can just write x squared, because again, that's going to be my value here. Instead of b squared, I can just use y squared, because that's going to be my value along this part of the triangle. And instead of c squared, I can just write an r squared, because r is going to be my hypotenuse value. Okay, and so I said our goal was to take a known equation and convert it so we're using the center hk, the radius r, and x and y, and we've accomplished that, which means what we have here is actually the circle equation. Okay, so this is the equation of a circle. okay, with the center 0, 0, and radius r. Okay. Now, if we had more numbers to put in, like in other words, we had the radius value, we could stick that in. I know that maybe this is an unknown quantity, like where is this 0, 0 showing up? But like what we have accomplished in really just a short few steps is that we now do have a circles equation. Now, again, I know this kind of seems weird, so let me pull up Desmos again. I want to show you something. Okay, so if I clear out, let me clear out all this extra line stuff. 1 second here. Okay, so I can prove like this kind of equation format does graph a circle. I can just type in x squared plus y squared equals, and we'll just choose a radius here. I'm just going to say my radius is 25 or equals 25. Okay, and so that's going to be the same as like 5 squared. And so you see right away we end up with a circle here. The center is at 0, 0, just like the one that we had. And we have a radius here of 5. We squared to get 25, of course, but like the radius itself is just 5. Okay? And we can repeat that, and so we can have like x squared plus y squared. And then we just choose, I don't know, like 64 or something. And 64 is, of course, just going to be h squared. And so we can see we have a circle centered at the origin, so with a radius here now of 8. Okay? And so this is like big monumental news. This is actually going to be the general circles equation. And so we can kind of make that additional note. Oops. Okay. All circles will use this general format. Okay, and so the big takeaway is this. If we understand that equation is just kind of map x and y values, and we can start with a known quantity, if we map out the key features of a circle, we quickly reveal that it's really just controlled by a right triangle. Right triangle means we have Pythagorean theorem in play, and so we just have to convert the a's, b's, and c's to x, y, and r's, and boom, we have a general circle equation. Okay. And so, like, the question we should ask immediately then is, like, what happens if we're not at 0, 0, right? Because I did say we have to, like, use the HK somehow, but it didn't really show up in this circle's equation. But what happens if we kind of move it off the grid, right? So what happens if the center's not at the origin, but instead some other place, h comma k? Right? Well, we should start this really the same way. We should go ahead and label this x, y. I'm sorry, HK. Okay, we should pick a radius. Okay, and just really pick it to any one random point. Okay, and then we can label this point x comma y. Well, we should approach this the same way. We should think about dropping a right triangle here. But I think the difficulty is going to be coming with like the distances. But I think if we're careful, we should be able to figure this out. Again, let's go ahead and label this point, and we'd be super careful here because if we notice this is going to be on the same horizontal line as my center HK, and so it should take the same y value. Okay, so this is going to be something comma k, but it's on the same vertical as my upper point, which means it should have the same x value, which is just x. Right? So in terms of distances, if we want to know how long this bottom line is, well, we are going from x, or h to x, and so this should be exactly x minus h long. Okay. In terms of the change in y values, well, we're going from k to y, and so a subtraction problem, y minus k, should actually take care of this distance. Okay. And so if we're setting up the Pythagorean theorem again, just like we did before, if we want this circle's equation, we should start with a squared plus b squared equals c squared again, because we still have that right triangle. But in terms of the a value, instead of just simply x, we now should have x minus h. Instead of y, which is like this guy up here, we should have y minus k squared. And that still should be equal to the r squared value. Okay? And so with a quick adjustment, if we don't have a center at h comma k, I'm sorry, at 0 comma 0, we have a modification of the circles formula. Okay, and so we can make a note here. This is a circles formula. If the center is not at the origin, but instead at h comma k. Okay. Now again, let's go back to decimals one last time on this, and get some proof out of this. So if let's say I shift my circle, so let's say like x minus 4. I'm just kind of picking some random numbers here just to demonstrate the concept. So we have y, let's say plus 2 squared, and we pick some radius value. Let's make it 4. Now let's make it bigger than that so it's easier to see. Let's say 49. So the radius value here is 7. So 7 squared. Okay. You can still see this is going to produce the equation of a circle. I'm sorry, the picture of a circle. Okay. But the center here is going to be hk. Now, do be careful because it's x minus h, y minus k. And so the center here is actually going to be, and I'll map it out, it's going to be 4 comma negative 2. The reason why it's going to be 4 comma negative 2 is because the general circle equation is x minus h squared plus y minus k equals r squared. Okay. And so like the thing to note here is that you have like the negative h, and so that means the negative as part of this formula is going to be natural, and so the h value itself is just going to be 4. Here you have a plus 2, and this is going to be a minus k, and so the only way to go from a negative back to a positive is to use a negative number here as well. Okay? And so that's going to be something that we probably want to take note of. But 2 is going to be quite tricky. Like when you get a circles equation, you're going to have to reverse the values because the h and k come as a subtraction problem. Okay, and so the h and k is always going to be your center of the circle. Okay, now we've had the grid for both these examples, but of course it now begs the question: how important was the grid to this anyway? Okay, and so in other words, can we like derive the circles equation even without a grid? And the answer is how important is the grid to circles equation? It's not very. Okay, meaning that we can kind of create that situation regardless of whether we have a grid behind us or not. And so even though you can't see the grid, we can still say we have a center HK. We can still say that we have like a radial value out to some point in the circle. Okay. And then from that, we can still create a right triangle. Okay. We can still determine values of our distances. So like this still goes from x to h to x, excuse me. Okay. And it's still going to be on the axis, so it's going to be comma 0. Because hk in this case is going to be 0 comma 0. And we can still determine distances. So this goes from 0 to x, and so this is going to be x minus 0, or just x. Okay, and then the right part of the triangle. Oh, I just realized you couldn't see any of that stuff. Okay, sorry about that. So pause for a second, catch up with me. So like now that we don't have the grid anymore, the question is it important to actually? I'm sorry. Given the last two examples, is it important that you actually see the grid, like the x and y values? And it turns out the answer is no, because even without the x and y values, we can definitely still recreate this, and that's where I kind of messed up and forgot to change the screens. Apologies. So I'm just recreating the distances here just like we did without the grid. And so the point is you don't actually need the grid to accomplish this task. So the equations can still start at a squared plus b squared equals c squared. Okay, and we can still substitute in values. So we can still substitute the x squared and we can still add the y squared, and that can still equal the radial squared value. Okay. And the thing we can make note of is this is the general equation of a circle at 0, 0. So if the center is at 0, 0, this is what the equation is going to look like. Of course, you're going to substitute in R value, but like that's in general what's going on. Okay, if we're not at the center, if we're not at the origin, and we just have some center h comma k, and it's not 0, 0, again, just like before, we can recreate the same exact situation. So we still have this radius r, and we still goes to some point on the grid. Excuse me. Oh man, x comma y. And we can still recreate the triangle, which will help us map these values. Now the trouble, of course, comes in with having to define this, but we can share the x value with the point above us, and we can share the y value with the point to the left of us, which means that this distance is really going from h to x, and so this is still x minus h, and the value up and down is still y minus k, which means when we try to recreate using the Pythagorean theorem, even without a grid, it turns out to be exactly the same. So this is still x minus h squared. This is y minus k squared. It's still going to be equal to r squared because it does follow the Pythagorean theorem. And this is a trick that you'll see pulled a lot in mathematics. Really, the Pythagorean theorem starts and ends a lot of conversations. And the thing I'd like you to note here is that this is a general equation, okay, for circles not at the origin. Cool. All right. So having said all that, let's actually put this to work. And so here are actually 4 examples. I kind of had to squish them in here to get them all to fit. But these are 4 distinct examples where I want you to find something having to do with a circle. Okay. And so the first thing is I want you to find the critical information here. So what are the critical info? Okay. Now when I say critical info, really what I'm talking about is center and radius. And so I want you to be able to pull 2 things here. One is going to be the center, h comma k, and the second thing will be the radius, which is just r. Now, either way, we should start with the general equation below it. So this is x minus h squared plus y minus k squared equals r squared. And that's going to help us pull these values actually quite quickly. Well, you notice the h and k. Okay, so you have the h, the h, the h. Here you have the k, and the k. We should be able to pull these values directly. So the h value is just going to be 2. The k value is going to be -1. Now, if you're wondering about the -1, please note that right here we have a negative in the formula, and then it turns to a positive in the equation. Well, the only way to go from a negative in the formula to a positive in the equation is if the number that you're using is also negative, because negative on the formula, negative in the problem would be a positive in the equation, or for the center. In terms of the radius, okay, we have to note that equals r squared. So r squared is equal to 16, which means r is actually equal to 4. Now, in truth, r is equal to plus or minus 4, but since it's a radius, we can't have a negative value, and so we'll keep it as a plus 4. And so for this equation, the center is at actually 2 comma -1, radius is 4. Okay. So here I want you to do 2 things. I want you to get critical info, okay, and then graph. Okay, I'm getting critical info again the first step. So we have x minus h comma squared plus y minus k, and the squared is equal to r squared. And so let's pull the h and k value first. Okay, so the h comma k center Well, again, we have h here, we have h here. It stays negative, and so that means we're just going to pull a 1 for x value of the center. We have k here. Here we have it now changed to a plus, and so that'll be a negative 3. And so that means we're center. Okay, the center of the circle is at 1 comma negative 3. And then we have to pull the radius value. Okay, so r squared is equal to 4, which means r is equal to 2, and so the radius is equal to 2. Okay, now we can put that to work. Let's go to the graph. We want to first make our center at 1 comma negative 3. So 1 over 1, 2, 3 down. So that's our HK center, 1 comma negative 3. And then we want to graph a radius of 2, which means we have to kind of go in every direction out 2 values. Okay, and then we just have to kind of roughen our circle the best we can. Okay, and that's going to be our circle. But the pertinent skill here is still pulling the center radius off that grid. Cool. All right. So here we're not given an equation. Let's write the equation. Equation equation. Okay, cool. Which means we have to pull the pertinent info, and so we need to pull the center. But we can do that. It's going to be negative 1, 2 up 1, so negative 2 comma 1, and that's going to tell us our h comma k. And then we need to pull a radius. Now the easiest way to pull a radius is to start at the center and just go up, down, left, or right. Remember, the radius is the same in all directions, so it doesn't really matter which. I was going to go straight down. So it's 1, 2, 3, 4, 5, and so r is equal to 5. Okay, so now we can put this into an equation. So we have x minus h squared, we have y minus k squared, and that's equal to r squared. That's our general equation. We just have to fill it in. So we're going to take x, and we're going to subtract our h value. Well, if I subtract h, that'll be plus 2, because it has negative 2 as our h value. So we have y minus k. That's going to be a straight up negative 1 squared. And then our r squared value, well, r is 5, and so this should equal 25, because we have to square that value if we can. It is perfectly acceptable, like if you wanted to write this equation, x plus 2 squared, and then y, whoa, got away from me. Y minus 1 squared is equal to 5 squared. You could do that. There's no problem with that whatsoever. Okay, so you can totally do it. Last one, what if we have a circle with the hk that passes through the point 3 comma 9? Well, let's start with this. So we have x minus h comma squared, and then y minus k quantity squared is equal to r squared. Let's get the part in that we know, which is going to be the h and k. And so like we're looking for x plus 3, because we have a negative here, and then we have a negative in our formula, so it's a plus 3 value. Y minus 1 squared, and then we have the r squared value. Now, we can't leave it here. We actually have to work out what the radius is going to be. Now, what might help is to get a visual. Now, this is not going to be perfect, but here's the situation. We have a center at negative 3 comma 1, and then we have this point at 3 comma 9. And so like 3 comma 9, something way up here, we have the points that we're trying to deal with, right? And so what we need to figure out is what's this radius value between them. Okay. Well, this is not new. We just had to figure out a distance, just a length, right? And so we can do that several different ways. I'm going to use the distance formula because I should be able to pull the change in x squared and the change in y squared quite quickly. Okay. And so change in x goes from negative 3 to positive 3. That's a change of 9. And then the y goes from 1 to 9, that's a change in 8. Okay? And so that's going to be 81 plus 64 under the square roots. Okay, let's see if I can do arithmetic right now. That's 14, so it's 14, 145. And so our r value, our radius value itself, is 145, right? And so we have to get that r value right here. But please notice the r value is actually squared. And so the way I'll write this in this final form will be x plus 3 squared, y minus 1 squared, and I'm just going to make it equal to 145. Okay? Now the reason we make that equal to 145 is because we are going to square the r value, and so we'll take, if r is equal to square root of 145, we'll take r squared to be equal to 145, because you're just going to square both. And the square and the square root cancel, and so r squared value is 145. And so that's going to be the equation, that one. Okay, guys, now those were lengthy. We're looking at almost 35 minutes worth of notes here. But like the big skill, the big question, if you kind of check back to it, is how can you define a circle both by description and equation. And so like, we definitely describe a circle being a round thing, two-dimensional, no vertices, only curves. But if we start to look at the definition, it's a collection of points. That leads us to an ability to kind of grid this out using the critical information from the definition, a center HK, a radius R, to any point x, y in the circle. And if you kind of think about how algebra equations just map all the x and y's, and we can start with a known quantity, so it's really just modeling off the Pythagorean theorem, and then we convert it to use x and y points and then a radius value. We have a couple different forms here, but in the end, we end up with two equations. One equation, if you have this as a center at 0, 0, and a whole other equation if you have that center at h comma k. And so we can immediately start putting that to work, either looking at an equation and reading it, being able to pull the center and radius out of it, excuse me, or being able to create the equation given critical information, whether that be from a graph, okay, or whether that be from some information point-wise, right? And so like, please take a second, catch your breath, do a review, and then I have several levels of practice for you at the front of the board, all right? So that's what I have for you. You guys have a wonderful day. Sorry that the notes are so long, but that's how it goes sometimes. You know it. It's math. What can you do? All right, so get some practicing with equations of circles, and I'll see you next time.